Recording in progress.
Yes, I'm audible, Pauli. Audible to you.
Yes, sir.
Yes, sir.
Last day we have discussed rotational spectrum. Yes, no?
Yes, sir. The colors and
Yes, sir.
in the polyatomic
Polyatomic.
rotational spectrum.
Yes, polyatomic. Yes. Then let me start. Polyatomic molecules. Polyatomic is completed and in left.
No, sir.
No, sir, that was
continuing at that time. The colors ended.
Yes, okay.
We have just started.
Yes, let me start. Yes. Yes, let me start. What is polyatomic molecules and how many types? What the main application of polyatomic molecules in rotational spectra?
Yes, sir. Sir, in the simple language, we have simply we have discussed that for a simple diatomic molecule, we have calculated the energies and but in reality, the molecules are polyatomic in nature. So, due to their different type of shapes, there are some types of 4 types of polyatomic molecule. So there are 4 types of polyatomic molecules. One is linear.
Yes.
Another one is symmetric top. And in symmetric top, there are 2 types. Initially, for linear, we can consider, for example, OCS. OCS. So in this case, we can see that there are because in the molecule in rotational spectra, we are dealing with the rotation of a molecule, and due to rotation, there occurs a change in moment of inertia. So, if for a linear molecule, usually in a molecule there should be 3 types of moment of inertia in 3 directions. But for linear molecule, due to rotation through its own axis, the change in moment of inertia considerable. So in this case, the moment of inertia through this, for example, IA will be 0. But the end-to-end rotation of this molecule, that means if we rotate this in this direction or through this axis, then we will see that there are 2 types of moment of inertia, and the value of those 2 moment of inertia is equal. That means we can see that IB equals to IC and IA equals to 0 for this case for the for linear molecule. But and we know that moment of inertia is proportional to is equals to mu r square, where r is the internuclear distance. For a diatomic molecule, r is fixed. But if we consider a triatomic means polyatomic molecules, then r will be different because we have to consider this bond length and also this bond length CO as well as CS. And we know that the molecule rotates molecule rotates with the center of gravity. So we have to consider the both bond length from center of gravity. For that, if we calculate the energy, in that case, we have to include both the moment of inertia value. for a polyatomic molecule, the energy will be different from just a simple diatomic molecule, and this is for linear molecule. If we consider that if it goes into symmetric top molecule, in this case there is two types. One is prolate and another one is oblate. In this case, for example, prolate, you can have CH3N. For this molecule, this is not a linear molecule. So through the rotation through the principal axis will give some changes, because through the axis moment of inertia, which IA is not equal to 0, which is unlike the case of linear molecule. So in that case, we have to consider the three moment of inertia value. And for symmetric top, the condition is IB is equals to IC, which is not equals to IA. For symmetric top molecule, this is the condition. And in this, we see that there is prolate and oblate. For prolate, the condition is for prolate, this is IB is equals to IC, and which is less than equals to IA. In case of oblate, example is like BF3. In this case, the condition will be IB is equals to IC, which is greater than IA. So in a symmetric top molecule, we see that there are two types. One is prolate and another one is oblate. And the other types of polyatomic molecules is one is spherical top. Spherical top. For example, CH4. CH4. In this case, the condition is IB is equals to IC is equals to IA. The moment of inertia through the three axis will be same. But we can see that this molecule has no dipole moment. So this is microwave inactive molecule. We will not consider the spherical top molecules in case of microwave. And the fourth type is asymmetric top. Asymmetric top molecule, and in this case example is H2O. And in this case the condition is IA is not equals to IB is not equals to IC. So there are four types of polyatomic molecules.
Yes, good. Symmetric molecule is two types, prolate and oblate. What the difference between prolate and oblate?
Sir, in case of prolate, the moment of inertia through the principal axis will be greater than the other two, and for oblate, the moment of inertia through the axis will be less than IB or IC and IC.
Yes. What are the main uses of polyatomic molecules in rotation spectra? Uses, what the uses?
Sir, from the spectrum, we can calculate the value of B, which is rotational constant, and from rotational constant, we can calculate the moment of inertia of a molecule or the bond, internuclear bond distance, the bond length of a molecule.
Yes, good. Rotational is completed. Yes, next move on vibrational.
Yes, sir.
Yes, what is vibration spectra? What the main application of vibration spectroscopy?
Sir, in rotational spectroscopy, we consider that the due to rotation of a molecule, there may be the molecule uh, absorbs a radiation, and after that it will show some spectrum. But in case of vibrational energy, we consider the elasticity of a molecule. That means molecule, for example, a diatomic molecules, they are not, the molecule are not in the rest position. They are always vibrating, and due to vibration, they will absorb some radiation, and for absorbing radiation, it will show some spectrum. For this vibration spectroscopy, we can see the bond strength of a molecule, or the elasticity of a molecule. We can check from the vibration spectroscopy.
Yes.
That means if we
Yes, what
if we
the
consider a molecule H,
yes, functional group determination and identification of two compounds, same or different. Here, two applications of vibrational. Yes.
sir, sir, sound was not clear. Can you say it again?
Yes. Two main applications of vibration spectroscopy: functional group determination and identification of two compounds, same or different. Yes.
Yes, sir.
Yes.
Yes, sir.
What the range of IR regions? Near IR, mid IR, far IR? Vibrational.
Uh,
Do you have any idea?
Sir, 10 to the power 3 semi.
10 की power 3
semi inverse
centimeters.
centimeter.
What the source of near IR and mid far IR? What the source of near IR and far IR?
Sir, light source.
Yes, that source. Source of IR radiation. Near IR is Nast filament. Yes. Far IR is mercury arc. Next is molecular vibration. What is molecular vibration and how many types of molecular vibration in vibration spectrum?
Sir, in case of there are stretching vibration and bending vibration. Stretching vibration is in the plane of paper, and bending vibration is out of the plane vibrations. In case of stretching vibration, vibration is
Yes. Stitching and asymmetric. Yes.
bending. And in stretching, there are two types. One is symmetric stretching, and another one is asymmetric stretching. And in case of bending, there is in plane and out of the plane.
Yes. What is coupled vibration?
So, opposite vibration is
Coupled vibration is symmetric and asymmetric. Vibration is called is coupled vibration.
okay, sir.
And bending vibration is four types. In the plane, out the plane. In the plane, shocking and rocking. Out the plane, wagging and
Yes.
twisting.
Yes, sir.
Yes.
Yes, sir.
What the uses of molecular vibration in vibration spectroscopy?
Sir, we know that the molecule is formed due to some molecular arrangement, some atomic arrangement within the molecule. So, for a molecule to be formed, there may be some bond breaking or bond formation. So, due to vibrational spectroscopy, we know that the energy, the bond dissociation energy from the bond vibrational spectroscopy. So, how much amount of energy or how which frequency of energy we have to provide, we can know from this spectroscopy.
Yes. What is fundamental bands? What is degree of freedom?
Uh, So, in case of vibrational spectroscopy, from Schrodinger wave equation, we know that the selection rule is for simple harmonic oscillator. The selection rule is delta V is equals to plus minus 1. But this is in case of simple harmonic motion. But in real molecule, we know that the molecule is not behaves like simple harmonic oscillator. It is anharmonic oscillator type. So in case of anharmonic oscillator, the selection rule is plus minus 1, plus minus 2, and plus minus 3, and so on. But the higher vibration greater than plus minus 3 we will not consider because the energy gap will be very high, and this type of vibrations we used to uh, it usually not seen in the vibration, so we can eliminate that. We just we see that the selection rule is 0, plus minus 1, plus minus 2, and plus minus 3. And if we consider the population of vibrational levels due to from the Boltzmann distribution formula, we can see that the population of V equals to 1 divided by population of V equals to 0, that is nearly equals to 0.01. So what is the 1% of the ground state? So we usually neglect the absorption from the fast excited state. We used to consider the molecular absorption to the next level is usually we consider from the ground state. So if we calculate from the selection rule, that means if we consider the vibrational energy from V equals to 1 to V equals V equals to 0 to V equals to 1, then we will get the vibration energy, which is known as fundamental energy. Fundamental band, a fundamental spectrum. And if we consider the V equals to 0 to V equals to 2 level, that is our fast overtone, and the energy regarding V equals to 0 to V equals to 3 is second overtone. And we can see that this we can see in room temperature. But if we increase the temperature around 600 Kelvin, then we can see the population of fast excited level is quite high, and we can see the molecular excitation from fast excited state also. For that, we also consider that equals to 1 to V equals to 2, which is known as hot band. So we can see the 4 types of band in case of anharmonic vibration.
Yes. Harmonic and harmonic oscillators. Yes. Fundaments. Hot band. First overtone, second overtone. What is Fermi region is?
So I don't know. I have to study.
Yes, Fermi resonance is fundamental and first overtone. Two mixed transitions. Each called is Fermi resonance. Yes.
Yes,
What is Morse curve? What is Morse curve in vibration spectroscopy? What
yes,
is
sir.
potential energy versus bond length? Explain.
Yes, sir. Um, so in the case of vibration energy, we have initially used that if we consider the y-axis as energy and y-axis intermediate distance. If we consider the simple harmonic motion, then the curve will be like which and this is for simple harmonic motion, and it follows the Hooke's law. But in reality, the molecule is not simple harmonic motion. In reality, it obeys the curve like this. And this curve we can explain through this type of curve explained through Moore's law, and this curve is called Moore's curve. And if we consider the energy levels to this, then the energy levels will be this is for V equals to 1 state vibrational energy 1, and then sir, if we plot the energy levels in this curve, it will be for vibration level 1. It will be in this, and this is not 0. And if we increase the vibrational level, the energy will be like this. And in a very high V value vibrational level, the energy level will be crowded and merged with each other, and at a point the bond will break, and that in that case we will see that after giving in energy, it will be same. And this corresponds to the bond dissociation energy of a molecule.
Yes. What is hot band? Explain what is hot band.
Sir, hot band is usually if we see the population of the molecular level, vibrational level, with respect to the ground state, the population in fast excited state is very less. But in a high temperature, we can see the population in fast excited state is quite higher with respect to the ground state. So in that case, if we provide a specific amount of energy or radiation, then the molecule in the fast excited level can excite it to the next level. So for the radiation for the excitation from p equals to 1 to p equals to 2 gives rise to a spectrum which is called hot band. And since in room temperature it can't be shown, in high temperature around 600 Kelvin, we can see the excitation. So it is known as hot band.
Yes. What is 0 point energy?
So 0 point energy is the energy with respect to the vibrational level 1. That means the ground state. The energy of vibrational energy is written as equals half minus so if we consider p equals to 0, then the energy will be so corresponding to the energy level 0, p equals to 0, we can see that the energy will there is some value of energy which is not 0. So for the energy of p equals to 0 level, or the energy corresponds to the v equals to 0 level is known as 0 point energy, which is not equals to 0.
Yes. Next, what is the selection rule? Harmonic and harmonic oscillator.
Yes, sir. So for simple harmonic oscillator, the selection rule is delta V is equals to plus minus 1. And for anharmonic, delta V is equals to plus minus 1, plus minus 2, plus minus 3. And higher than plus minus 3, we neglected.
Yes. What is PQR branches? What the main application of PQ branches in vibration spectroscopy? Explain.
Sir, Sir, PQR branches are in case of linear molecule, we can see only P and R branches, and for the non-linear molecule, we can see PQR branches. So from the PQR branches, you can assume the structure of a molecule if it is linear or not linear.
Yes. What the main purpose of PQR branches in vibration spectroscopy?
Mm. So PQR branches come from the rotovibromic spectrum, model spectroscopy. Since we know that for rotational energy, the energy gap between two rotational line to rotational level is around 1 to 10 centimeter. And in case of vibrational spectroscopy, the energy gap between the two vibrational level is around 10 centimeter, 10 cube centimeter. So if we provide energy to vibrate a molecule, that means the molecule will vibrate in the rotation will also happen in this case. So in this case, we will get the spectrum of combined spectrum of vibrational and rotational spectrum. So if we combine and see the spectrum, then due to our selection rule, it can absorb energy, or also it can emit some energy from the higher level to lower level. So if we see the spectrum, then we can see that there will be some spectrum. So for one, it will be for delta V is equals to, in this case, the energy will absorb. That means it will be +1, or in this case, the delta will be -1, and the value with respect to the fundamental we can see. So in this case, these branches are called P, and in this branches are called R. So sir, to explain PQR branch, should we have to explain the Raman spectroscopy?
Yes. After Raman, yes. Next question is if effect of temperature on PQR branches. What will be the effect of increased pressure and temperature? What will be the effect? PQR branches.
Sir, I have to study it.
Yes. Bend extend on both sides and more lines in each bend appear. Yes. Intensity maxima in each branches move away from bend origin. Third, height of intensity maxima decrease. Yes, no. 3 point. Any limitation of vibration spectroscopy in IR? Any limitations?
Um,
Is no problem. You look them. you have to study about these. Yes, no.
Yes, sir.
Next, Raman. Are you ready for Raman?
No, sir, tomorrow.
Tomorrow. Yes, no problem. Some basic questions. Vibration. What is coupled vibration? Can you explain coupled vibration? What is coupled?
So the combination of symmetric and asymmetric stretching is the coupled vibration.
Yes. What is Fermi resonance?
So the fundamental spectrum and the fast overlap.
Yes. Good. Next, what is functional group region and fingerprint region? What is the difference? Yes.
So the functional group region is for the functional group having different molecules will show the similar type of spectra for the. There is a particular spectra for functional group, but the fingerprint region is different for different molecules. That means it is the identification of a particular molecule we can have from the fingerprint region. But for functional group, there are some particular spectra for particular functional group. From that, we can just assume that there is the presence of some functional group, but not the entire molecule from the functional group spectra.
Yes. What the range of functional group? No, higher region.
So,
Six.
11,600 to 3,000 or 4,000.
Yes, yes. 667 centimeter inverse से 4,000. Yes. और fingerprint region value?
So 300 to 600.
667 से 1,500. Yes, what the formula of vibration frequency in vibration spectroscopy?
Yes. So
Formula.
vibrational frequency
Yes, yes.
is 1 by 2 by root over of k by mu. Right, k is the force constant and mu is the reduced mass. And this is in Joule. Sorry, this is in Hertz. And if we consider in wave number, then it is 1 by 2 by c into root over of k by mu.
Yes. What the uses of this formula?
So from this formula, we can calculate the K. K is the force constant, means the strength or strength of a bond between two molecules. From this, we can check. We can.
Yes, reduce mass. Yes. Vibration frequency K. Yes, good. Next day, we will discuss in the left part of rotational spectrum. Yes, good work. Raman spectroscopy,
Yes,
Raman and electronic. Next day. Yes.
yes. Sir, the Jablonski diagrams and the Beer-Lambert law will be in this part. Will also be in this part.
Yes, Yablowski also. Yes, next day we will discuss.
Okay, sir.
Next day.
Yes. Okay, sir. Thank you, sir. Good night.
Okay, thank you. Good night.